So today we're talking about how you can tell whether two triangles are congruent. And the first thing we want to talk about is the symbols that we use to represent corresponding parts of congruent triangles. So looking at this diagram, how can you tell which side corresponds to side KJ? Well, you can tell by looking at the tick marks. See how KJ has one tick mark? MN also has one tick mark. So that means that those are congruent to each other. Now let's look at our angles. What about angle N? Well, angle N has 3 marks here. 1, 2, 3. So does angle K. So I can tell that angle K must be congruent to angle N. So let's write some congruence statements for these facts. We can say that JK is congruent to MN. And we can also say that angle K is congruent to angle N. These are considered to be corresponding parts, and since the triangles are congruent, the corresponding parts are as well. There's other corresponding parts in the triangles too. Let's write a statement for the entire triangle. To talk about the whole triangles and say they're congruent to each other, we would say that triangle JKL is congruent to triangle MNO. The order matters in this statement. Notice that angle J is congruent to angle M. Angle K is congruent to angle N, and angle L is congruent to angle O. In fact, just from looking at these statements, we can deduce some other congruence relationships. For example, we could say that JK is congruent to MN, that KL is congruent to NO, and that JL is congruent to MO just by looking at the statement. We can also confirm that with the tick marks and arc marks, but all of this illustrates that the order of the vertices in the congruence statement really does matter, and it really does tell you a lot. We have a congruence statement here that tells us that triangle ABC is congruent to angle XYZ. Let's add arc marks and tick marks that show those relationships. First, AB is congruent to XY. Also, BC is congruent to YZ. And AC is congruent to XZ. Notice how the corresponding sides have the same number of tick marks. We should do the same for the angles. Angle A is congruent to angle X, angle Y is congruent to angle B, and angle C is congruent to angle Z. One way to prove that two triangles are congruent is to prove that all of their corresponding sides and all of their corresponding angles are congruent to each other. We've marked all of those relationships on these triangles. That's a lot of work though. Let's talk about shortcuts that we could use. ASA stands for angle side angle. This is a theorem that tells us that if two angles and the included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So in other words, all we need to show is that two angles and the side in between them are congruent to two angles and the side between those for another triangle. Let's look at the example we have over here. Let's take a look at our angles first. I can see that this angle has 2 arc marks, so it must be congruent to that one. And this one has 1, so it must be congruent to that one. So I have 2 pairs of congruent angles here. And in between them, I have an included side. So this side right here is in between my angles. That's what it means to be included. It means to be in between. So I know that an angle, a side, and an angle are congruent to an angle, a side, and an angle between my bottom and my top triangles here. That's sufficient to tell me that actually all of the corresponding angles and all of the corresponding sides are congruent. Whenever 2 angles and an included side of one triangle are congruent to the corresponding angles and included side of another triangle, those triangles are congruent. That's what angle side angle means. Here's an example of this. These triangles are oriented differently, but we can use angle side angle to show that they are congruent. First of all, I know the measures of an angle, a side, and an angle on triangle ABC. To have a similar relationship with triangle DEF, I may need to find one more angle. I know that angle D measures 35 degrees, and I know that side DF has a length of 5.7 centimeters, but I don't immediately know the measure of angle F, but I could figure it out. I know that every triangle has interior angles that sum to 180 degrees. So 35 plus 80 plus the measure of angle F must equal 180. So the measure of angle F must be 65 degrees. Okay, so now I know that. Does it match my other triangle? Does it match ABC? Yes, it does. 35, 5.7, 65. 35, 5.7, 65. So by angle, side, angle, triangle congruence, I can say that these two triangles are congruent. Let's write a congruence statement. Angle A is congruent to angle D. Angle B will be congruent to angle E. And angle C is congruent to angle F. So I would write that triangle ABC is congruent to triangle DEF. And that's by angle, side, angle, triangle congruence. Now let's talk about the side angle side theorem. This is another shortcut you can use to show that two triangles are congruent. For this case, you want to look at two sides and their included angle. So here I have a side, an angle, and a side that are congruent to a side, an angle, and a side of another triangle. And what I want you to notice is that in both cases, the angle is included between the two sides. Remember, included means in between. Here are a couple of examples where you could use side, angle, side to tell whether two triangles are congruent. On the example on the left-hand side, one thing you'll need to do is mark the side that is shared by those two triangles. By the reflexive property of congruent, we know that a side is congruent to itself. It sounds weird to even say that, but sometimes it's useful to think about. So here we have a side, an angle, and a side. A side, an angle, and a side. So side, angle, side congruence tells us that those are congruent angles, congruent triangles. Similarly, we can use side, angle, side to tell that these two triangles on the right side are congruent as well. Side, side, side triangle congruence may be my favorite. It's one of the easiest to follow. It says that if three sides of one triangle are congruent to three sides of another, then they are congruent. So here you're just looking for three pairs of congruent sides. If you can find three pairs of corresponding congruent sides, then you have two congruent triangles. So take a second to look at these triangles and see, how could you tell, are they congruent or not? Starting at the left, our first pair of triangles is congruent by side, side, side triangle congruence. What about our next pair? It looks like we don't have enough information because we just have a side and a side on each triangle. But wait a minute, we know that vertical angles are congruent. So this included angle between those sides is also congruent. That means we can use side, angle, side to determine that those two triangles are congruent. On this third example, we have a side, and an angle, a side, and an angle. Well, that's actually not one of the theorems we're using. In fact, that's not a triangle congruence theorem at all. It's important that the angle be included between the sides. And in this case, that's not what's going on. So we cannot tell. I'm just going to write nope. We don't know. Now let's look at this next pair of triangles. A side is marked on each triangle and an angle. What else do we know? Well, we also know that this third side here is congruent because both triangles share that. By the reflexive property, that side is congruent to itself. So we can say that these two triangles are congruent by side, angle, side. There are a couple more ways that you can use shortcuts to see whether triangles are congruent. There's angle, angle, side. For this one, what you're going to look for is two angles and a non-included side of one triangle that are congruent to the corresponding angles in the non-included side of another triangle. So in other words, here we have an angle, and the side that is not between those two. So we go angle, angle to another side. Angle, angle, side. Here's a flow chart that can help you kind of figure out which of those two theorems you might be able to use. This first example represents a case where we would use angle, side, angle. The second case has an angle and then two sides, but the angle is not included between the two sides. It's not in between them. So we cannot tell that those two triangles are congruent. And in the third example, we have an angle, and a side. An angle, and a side. So in this case, we would use the angle-angle-side triangle congruence theorem to demonstrate that those two triangles are congruent to each other. Finally, you can also use the hypotenuse-leg triangle congruence theorem to tell whether two triangles are congruent. It says that if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and corresponding leg of a second right triangle, then the triangles are congruent. So one thing I want you to be mindful of is this theorem is only usable with right triangles. So they have to have an angle that measures 90 degrees. So here's some examples down here. I can see that I have right triangles, and I have the hypotenuse of each of my right triangles, and I have a leg. It doesn't matter which leg I have, as long as I have one leg and I know the hypotenuses are congruent, then I can use hypotenuse leg. That works here as well, because I have two right triangles, I have a leg of each right triangle, and by the reflexive property of congruence, I know that their hypotenuses are also congruent. So why are these non-examples not examples of hypotenuse leg? Well, for this first pair, it's because they are not right triangles. Now, this second example down here, these are actually congruent by side angle side, but not by hypotenuse leg. Why not? Because it doesn't tell me that the hypotenuses are congruent. So therefore, to show congruence here, I would need to use side angle side, not hypotenuse leg. So can we use hypotenuse leg to show that these triangle pairs are congruent? Well, in our first example, we have right angles, and we have a leg for each right triangle, but we don't have the hypotenuse. So nope, we can't use it there. On the next example, we have two right triangles, and we have a leg and a hypotenuse for each of them that are shown to be congruent. So yes, we can use HL for this one. On the next one, we have two right triangles, so that's a good start, and we can see that they share this common leg. Are the hypotenuses congruent? So at this point in our geometry instruction, we don't necessarily know this, but I can tell that looking at this shape, what I have is a parallelogram. And something that's always true about parallelograms is that their opposite sides are congruent. So yeah, actually we do know that since this is a parallelogram, these hypotenuses are congruent. But we're not actually going to learn that until next semester. So it's okay if you don't know it right now. Just trust me, those hypotenuses are congruent because this is a parallelogram. And since they're congruent, yes, we could use hypotenuse leg to tell that these triangles are congruent. You're not likely to see a tricky one like that. But if you did, you'd be ready for it. So those are the ways that you can tell that triangles are congruent. We have side, 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 angle, side, angle, angle, side, angle, side, angle, and hypotenuse leg.